This is the 11th video of my series, Casting Shadows, and this one's about shadows of boxes on the wall. And I want to remind you of my book on Amazon, where the Kindle version is only $5. Let's find the shadow of this horizontal pole on a wall. We set up the seat rectangle so that this part is either parallel to or converging with the pole, and the shadow lies on the seat rectangle. Its end depends on where light hits it. So if the light hits it here, then the shadow is vertical on the wall. If the light hits it down here, then we have a horizontal component before we get to the vertical component. Now, since the shadow vanishing point and the object vanishing point are the same, three things are true. One, the shadow follows the seat rectangle, the shadow on the wall is vertical, and there are no shadows to the side of the box. Now, what happens if the shadow vanishing point is different from the object vanishing point? So again, we have the seat for the tip of the pole. This time, however, the shadow direction does not follow the seat rectangle, and when it hits the wall, it goes vertically up until it intersects the light, and then it goes to the back of the pole. So we have this diagonal shadow. Now, what if the light hits the ground? Then the the line goes from the seat rectangle in the shadow direction, and when it intersects the light, it goes toward the vanishing point for the object. And when it hits the wall, it goes to the back of the pole. So we have two components to the shadow. Now, this is a pattern that happens everywhere, which is from a vertical pole, the shadow goes in the shadow direction, and when it intersects the light, it converges with the box, just as it did here. So since the shadow vanishing point is different from the object vanishing point, three things are true. The shadow doesn't follow the seat rectangle. The shadow on the wall is a diagonal, not a vertical, and there are shadows to the side of the box. This is the horizontal pole that casts this diagonal shadow on the box and this little shadow on the ground. So let's try to find these. First, draw the light ray so we know the direction of the light, including a light ray from the tip of this pole to the tip of its shadow. Then establish a seat from the tip of the pole and draw the shadow direction until it intersects an extension of the box, as if the box had been longer. Even though it hasn't yet intersected the light, it now converges with the box until it does intersect the light at number 3, and that's a point on the shadow. Another way of doing this is to establish another pole between these two poles so that when we draw the shadow direction, it hits the box, goes vertically up to number 6, and that gives us the direction of this shadow. To find the shadow of this triangle, turn it into a shape that we know, like a horizontal rectangle, and then find the seats of that rectangle. And for each point on that rectangle, we're going to draw lines, light lines from above and shadow lines from below to get these intersections here and here. And then they follow the rectangle in the same direction until they hit the wall, and then they go to both sides of the rectangle like that. And then finally just change the shadow so it relates to this triangle. One approach to shadows on the wall is to find poles that are close to the light and extend them down. And when they intersect the light, that would be the beginning of the shadow. The shadow follows the box until the next intersection, then up until the third intersection, and then it goes to the corner of the box. In the side view, in this case, we happen to have two poles that we can use, and then we can find the shadow pretty easily. Now, this one on the ground also has two horizontal poles that we can use. Now, in all of these cases, we don't really need the shadow direction. In fact, the only place where we can identify it is here on the horizontal box. Here's a shadow of a box on the wall using a wall vanishing point. And as I described previously, to find that point, you go to the floor vanishing point horizontally across until you reach the edge of the room, and then vertically up until you're level with the light. And that's the wall vanishing point. And it goes through the back corners of the box that are attached to the wall. We have light rays then going through the front corners of the box, not attached to the wall, which I call floating corners. So let's see how this works. Let's try to find this point on the shadow. So the light goes through the front corner. Now let's make this pole here, this horizontal pole, the one that we're working with. So in that case, the shadow goes through the back of that pole to intersect the light right here. And you can see that, for example, number 3 here, we use this pole, the light goes to number 3 on the shadow, and the shadow direction goes through the base of that horizontal pole right here. The shadow of this box on the wall is front lit. In other words, the pseudo-sun is down here, and the vanishing point for the shadows is here on eye level. And here's the box, which is above eye level, so we see its bottom. And it's on the wall, and we want to find its shadow. So we need to draw light rays through the front bottom corners. Then we need to find seats, and the seats go on the floor, and the back seat is right against the wall. And we make sure the perspective of this seat matches that of the box. In other words, they go to the same vanishing point here. Then, to find the seats, the shadow line, we start here with number 1 and go down to the base of its seat, which is number 2. Then it goes toward the shadow vanishing point here, number 3, until it hits the wall. Then it goes up to number 4, and when it intersects the light at number 4, that's a point on the shadow. Same over here with number 5. Go down to the bottom of its seat. The shadow line will go toward the shadow vanishing point, and when it hits the wall, it goes vertically up, and where it intersects the light is a point on the shadow. Let's say this is a box on the wall in front of us, so it's protruding out, and the light is coming down in this direction, and so this side is shaded, and these areas are light. Now, if we want to draw its shadow, we need to find point 3, and the only way we can do that is with the side view. So this side view shows the box on the wall, which it should be, and it happens to have beveled edges. So start with lining up both views, the top and the bottom of both views. Remember, we don't have the shadow yet. And then draw a light ray from number 1, this corner up here, down to the wall. And do the same on the side view. Number 1, the point protruding out down to the wall. And we know where this point is because the light hits the wall there and obviously can't go any further. So we transfer that position to the front view, and where that line intersects the light is this number 3 that we're looking for. Then we don't need the side view anymore. We can go down to number 4, intersection 4, and then across to 6 and to the corner. But we could use the side view if we wanted to check it out. So let's say we have a light ray going from 2 to 4 there, and same in the side view, 2 to 4. Well, it has to stop here on the side view because that's the wall, and you transfer that position back to the front, and there is number 4. The next video is about shadows of boxes on inclines like chimneys on roofs. So we're really getting into the fun stuff now.